So this video is about my BC-250 case build. So I got this Meanwhile power supply. Looks like it's about the same profile as the card. So it's like either way you could do a thin profile system with this, like this. What I think I'm going to do is I'm going to flip it around and just run them in a small GPU sized box like this. I'll try this 80mm fan that came with the BC-250 chassis. These are pretty loud at full bore, but I think when they're spooled down they shouldn't be too bad. I also got these two Noctuas, so possibly I'll try putting two of these 60mm guys in here and see how it goes. So I haven't tried firing this guy up yet off the Meanwhile power supply. Just wired this in. It's got some nice screw connectors on here. This is a real beefy case on this thing. I'm surprised at the build quality for how cheap it was. I think I picked this up for under $20 on eBay for 350 watt supply, and just got one of these 16 gauge PCI-E cables, so it doesn't overheat, but beefy wires on this one for the length. Let's try hooking up one of these bad boys and see if this will fire up. Alright, let's try with the Noctua fans. Zero noise with these, oh my gosh. So I set the Noctua fans to full speed. They're still super quiet. But even just sitting here at idle, it's still climbing up to 58. It's been here for a couple minutes, so it may keep climbing up to 60C. I'm going to try out again, do a custom fan profile with the jet engine again. I'm kind of tempted to do a case design where I can swap out either of these. I like the idea of the low profile thin case, because these two guys together, once they're sandwiched, will come out about 70mm, so about the right size for two of these fans. Basically just blowing straight through a long narrow case like this. So I just did the fan control on this Cooler Master. It all the way down to 2%, which is crazy that it can still run. And it's keeping temps, it looks like lower, and then substantially lower than what the Noctua fans are doing. The problem with it is it does have a bit of a line to it. To build this case, I used some Western maple, firewood that a neighbor had cut down near me. So I had this basically as firewood and milled it with my bandsaw. Here are some of the already dried pieces. I'm cutting down to 1 centimeter thick for the sides of the case. That's a lot narrower than I've ever used before, but this is what I had on hand, and I've always wanted to build a PC case out of solid wood. It'd be much easier just to use plywood for this, and probably stronger, but I like the challenge of doing this and can't beat the price of it. It's just a lot of work to go through and process all of this, so this is putting it through the planer at the end to smooth out both sides before I can start using it to put a case together. But again, something like plywood or acrylic would be much easier than doing this. This guy like this. suspended somehow, so there's an air gap between the GPU and the power supply. Build some sides, like that. Hopefully it doesn't look like crap. There we go. Almost ready to go. So ship it. Most of what I'm doing in this part of the video is squaring up the top and side pieces. So using my track saw to make sure I have a square corner on each of them, and then in a minute running them through the table saw to make sure all the edges are parallel so they're ready to be glued together. One of the downsides of working with natural whole solid lumber like this is occasionally you get a split, especially when you cut them down to 1 centimeter. So that's what I'm doing here. Is there was a split that developed in each piece of wood, so just gluing up. Fortunately, this was invisible at all in the end product. This gap sealed up really well. Hopefully it stays that way. So one of the things I'm looking to do is create a piece. This is just going to notch into, and we can screw in both GPU. It's going to sit on there. And we'll have a stop at the back there. So we'll just come up to a stop. I'll keep it secure up and down, basically creating a rail for the card to sit on. about this point in the project, I had realized that I didn't like the way the PCIe power connector came off the side of the BC-250 card. It meant I had to basically make the case an extra 2 centimeters wider just to accommodate the power connector. So I decided to desolder the PCIe power connector here and bend the lead so that instead of pointing out to the side of the card, it pointed it straight up. I thought this would be an easy job that would take 20 minutes or so, or maybe an afternoon. I actually spent probably 3 days going in and out of off my bench trying to figure out how to desolder this whole thing. You can see right here I had way too much oxidation on my tip. I haven't done a whole lot of soldering like this, so this will probably all seem pretty funny to people who are better at electronic soldering. But eventually got it all off. I think one of the channels that helped me a lot was NanoFix on YouTube. This is one of the tricks I learned from another channel. In order to solder out desolder a connector like this, where you have to heat up all 8 leads at the same time. If you solder a piece of copper wire between all of them, you can apply heat to all the leads at once, which helps pull out or melt all the leads at once, so then you can get a pair of pliers, or what I ended up using is a screwdriver to ease the pin out. So one of the things that makes this challenging is that I didn't really know this about the design of these cards. They have a ground plane that goes through the middle of the board as well as a power plane. And that's a lot of copper, so as soon as you apply any amount of heat to these, it ends up dissipating through the middle of the board. I was really nervous doing this. You can see how much the board is flexing trying to get this out. I was surprised or very happy when it came out and I got everything resoldered and it actually worked. So right here you can see I'm about to get the connector out. It comes out, and then I thought I was almost done, but it was really hard to then clean all the solder out of the individual holes. That took me another day of desoldering and mixing the solder with a leaded solder, mixing between a vacuum tube and the copper braid. One of the things with the copper braid is almost as soon as you apply it, it ends up dissipating the heat into the board, and then it gets stuck to the board. So to do a lot of this, I have one of the nicer Weber soldering stations that are still for customers, and even having it turned up to the max with this job, it would still not be enough to desolder these. So I think I'm using a newer tip here and tried a few different tips as well. So you can see the solder cycle getting a fair amount off this. Probably here the soldering braid's going to get stuck to it. This is another YouTube trick that I had learned trying to figure out how to clean these holes out, was using a lead from an old resistor. There I have the power connector bent. I did that off camera, didn't capture the footage, and there, and just applying some flux. So this is the final part of getting it soldered back in, praying that it works afterwards. This was my first time powering on after getting the connector soldered on. So a little nervous, but it did come up as expected. So I managed not to break anything, at least for now. I am using the two 60mm Noctua fans for this first power on, taped in with some masking tape you can see there. Feed it into Bazzite. One of the things I was concerned about at this point was that they wouldn't be able to cool things appropriately. So I decided after this clip to go ahead and build a fan with the original 80mm BC-250 fans. Okay, CPU 64C just sitting there. And I think that fan's pretty close to its max. And I tried setting the Noctua fan to full speed here just to see what kind of temps I would get. It's still pretty quiet, but I'll try it again later. So just idling here with those two Noctua fans in it, 76 with the fans on full. It's not giving me a whole lot of headroom. I didn't capture the footage here, but what I'm doing here is measuring or just taking a mark of how much I can cut the cabinet down, how much I can cut the case down that I had built, since now I can make it 2 centimeters narrower since I no longer have to accommodate the power connector. So another piece of footage I didn't capture, sawed off one of the pieces of the board, now cleaning up the part from sawing apart the glue joint off camera, and I'm going to re-glue it so I can make the case just a little bit narrower. I'm re-gluing everything now after resawing the case to make it a little bit narrower. One of the things that's super helpful was this clamp set I got off Amazon. These are pretty common on AliExpress and eBay and Amazon. I really like this set. Makes it much easier to do small glue ups like this where you can't use dowels or dominoes or biscuits or anything like that. It's just too narrow to work with. I could possibly use brad nails, but it's just not worth dealing with any blowout that you would get. So I decided just to go with straight glue joints for all of this. I was originally planning to do this all by using hand tools, but I decided for the mount for the fan, since some of the dimensions were so small, I drafted something up in FreeCAD and took this small piece of scrap that I had. It's not even plywood, I think it's a leftover section from the panels I made, and had the CNC cut out all the holes in the mounting area for the 80mm fan. In a later video I'm going to try doing the Noctua fans again, see if I can undervolt or make some modifications, maybe modify the thermal interface, new thermal pads, see if I can get reasonable temperatures with the Noctua fan. But for right now, at least the first iteration, I'm using this Cooler Master fan from the BC-250 chassis. This is some automotive guide coat that I had laying around for a auto body project. I've never used it for sanding wood before. I figured I'd give it a try here. It worked, I'd say, reasonably well, it being able to determine which parts needed more sanding, finding any low spots. So I think I would use it again for this purpose. For finishing this, I went with some Danish oil, just not tinted at all, just the regular, I believe it's Watco brand. I'll leave a link in the description. And after that dried, you'll see in a bit, I put on 3 coats of spray lacquer. Yeah, so using that server fan in this was probably a mistake. Right here you can see it at idle, but with the fan profile, once it spins up, it's super loud. So I'm going to be doing a follow-on to this. Here you can see it really screaming. I adjusted the fan profile so it doesn't get this loud, but it's still too loud for my taste. So I'm going to do a follow-on to this video. Trying the Noctua fans and also doing a thermal pad replacement and do a comparison. At least for first install though, this is good to make sure I have adequate cooling to experiment with some overclock settings. So right here I'd set on just a 2000 megahertz clock for the GPU. And probably can't even hear me over this. And 1 volt. So here you can kind of see it peaks up over 80, 60, and the fan is, it's hard to believe this isn't even 100%. This is maybe 80% on the fan, how loud these BC-250 fans are. Yeah, it's crazy at full bore. But I want to see how good I can get this with the Noctua fan. Like, this is just too loud for me, but it's, I don't know, kind of funny. Anyway, I've tried playing, I think Elden Ring's the only game I have that's really a common one that's used in these benchmarks. And I probably have to play around with the settings. You can see quite a bit of stuttering here, but it was only getting around 30 frames per second, so that's another thing to see. I think some of the game settings I'm probably going to have to change. Anyway, I think that's probably enough for this video. So, thanks for watching this far, and let me know what you guys think.